Welcome to today's dramatic reading of the song Wrecking Ball by Miley Cyrus. Don't you ever say, I just walked away. I will always want you. I can't live a lie, running for my life. I will always want you. I came in like a wrecking ball. I never hit so hard in love. All I wanted was to break your walls. All you ever did was wreck me. Yeah, you. Now, that that's out of the way, let's get to factors, all right? We're going to talk about factors. What are factors, Mr. Quick? Well, factors, two or more numbers that when multiplied together form a product, all right? Mr. Quick, this is what you're saying. Mr. Quick, you're crazy. What does that mean? Well, don't fret, my fourth grade friends. It is simple, right? 2 times 3 equals 6, right? Yes, you know that, okay? 6 is the product because it is the answer to a multiplication problem. That's what a product is. So 6 in that example is the product. 2 and 3 are the factors of 6. They multiply together to equal 6. So 2 and 3 are factors of 6. Are there any other numbers that can be multiplied to equal 6? Sure, 1 and 6. So the factors of 6 are 1, 2, 3, and 6. Get it? If not, you will. All right, let's look at the number 12. What are the factors of the number 12? A couple different ways to do this. I would like to make a little factor tree. Put my number up here. All right, I've got the number 12. I just start with 1 and the number because you know those are always factors. So I put 1 here, and I'm going to put my 12 down here at the bottom of my tree, kind of at the root of my tree. And I'm going to connect the two, 1 and 12. Let's move on to the next number, 2. Can 2 be multiplied by anything to equal 12? Sure it can. 2, and I'll put my 6 down here again. 2 times 6 equals 12, so they're on the list. All right? What about 3? That's my next number. I did 1, I did 2, now I'm going to do 3. 3. Can 3 be multiplied by anything to equal 12? Yes, it can. So I put it on the list. 3 times 4. All right? What's my next number I'm going to look at? Well, 4 is my next number. 4 is already on there. Once you hit that double number, you're done. So the factors of 12 are 1, 2, 3, 4, 6, and 12. Pretty simple, right? Here's what I'd like you to do. Pause the video right now. You're going to write down the factors, okay? And then when we come back tomorrow, I want you to be able to tell me. So I want you to write down the factors of 10, of 20, and of 15. We're going to continue, but if you want to pause that video, you can do that at home, and then we'll move on. All right? Prime numbers. Let's look at prime numbers. Numbers that only have 2 factors. 1 in itself. The examples I put were 5, 7, and 17. Well, let's look at 5. We make our little factor tree for 5. Well, I know 1 and 5 definitely multiply together. Is there anything 2 can be multiplied by to equal 5? Let's see, 2, 4, 6. No, I skipped 5, so 2 doesn't work. Okay, I'm not going to write down 2. What about 3? 3, 6, 9, 12. No, that doesn't work. 3 doesn't multiply into 5. What about 4? 4, 8. No, I skipped 5. What about 5? Well, it's already written down there. So my factor tree is done. Since 5 and 1 are the only factors of 5, it is a prime number. 7, same thing. 17, same thing. Can you think of any other prime numbers? Write some down. Bring them tomorrow. We're going to move on. Composite numbers have more than 2 factors. I wrote down some examples. 6, 12, 14. All right? Let's do one just for the heck of it here, okay? 6. Well, if I start at 1 and 6, okay, it's at least a prime number because it obviously has that, but let's see if it's a composite number, which has more than 2 factors. Can 2 be multiplied by anything to equal 6? 2, 4, 6. Yeah, 2 times 3, right? So 2 and 3 I'm going to write down, all right? What's my next number I'm going to look at? I did 1, I did 2, now I'm going to do 3, but 3 is already up here. So my tree is done, but 1, 2, 3, and 6 are all factors of 6. So that shows me that it is a composite number because it has more than just 1 in itself. Let's look at greatest common factor, okay? This is an easy one once you get the factors in, okay? Greatest common factor of, let's say, we'll do 12, and we'll do 18. If I said, what is the greatest common factor of 12 and 18? What you can do is make a little chart just like this. On one side, you write the factors of 12. On the other side, you write the factors of 18. And we'll see which one of all those factors is the highest. Because greatest, right? Greater than, greatest, highest. Let's do 12 first. We'll start with 1 and 12. Okay? Can 2 go into 12? 2, 4, 6. Yeah. 2 times 6 gives us 12. Can 3 go into 12? 3, 6, 9, 12. 4. 3 times 4. Yep. What about 4? Oh, it's already up there. So our factor tree for 12 is done. Let's do 18 now. 18. Well, we know 1 and 18. That's a no-brainer. Does 2 go into 18? Yes. 18 divided by 2 is 9, so 2 and 9. 18. What about 3? 3, 6, 9, 12, 15, 18. Yes. 3 and 6. Okay. What about 4? 4, 8, 12, 16, 20. I skipped 18, so 4 does not work. What about 5? Well, 18 does not end in a 0 or a 5, so 5 doesn't work. What about 6? 6 is already up there. So my factor tree for 12 is done. The factors of 12 are 1, 2, 3, 4, 6, and 12. The factors of 18 are done. 1, 2, 3, 6, 9, and 18. Let's see which one is the greatest factor. See which one is the greatest factor. They have 1 in common. They have 2 in common. They have 3 in common. They have 6 in common. They do not have 4 in common. They do not have 9 in common. And they do not have 12 or 18 in common. Which of those? They have all. These are all common factors. But which one is the greatest common factor? It's 6. So if I asked you, what is the greatest common factor of 12 and 18? You would say 6. That is all the time we have today. I must get back to dramatically reciting Breaking